Hi everyone, my name is Haftam Bankar, your grade 11, grade 9 and 10 maths teacher. ካብዚ ቀፂልና ያው ስለ ሴት ቲዮሪ ክንመሃር ኢና ኦብጀክቲቭ ኣለና ሰለስተ ኦብጀክቲቭ. So in today's class we are going to see the types of sets. We are going to see also the operation on sets, and we are going to do some examples based on the concept of set theory. All right, so to start the concept of set theory, let's define what a set is. So students, from your grade 9 concept, I'm talking about grade 10, a set is a collection of distinct objects considered as an object in its own right. Those objects can be numbers, letters, symbols, and so forth. So a set is nothing but it's a collection of objects, and those objects can be letters, it can be numbers, symbols, and so forth. So usually a set is denoted by capital letter, okay? A set is denoted by capital letter. So having this definition and notation, we have types of sets. So let's start by element. An object that belongs to a set is called an element. Say for example, if X is an element of a set A, then we write X belongs to A, or X is element of A. If X is not an element of A, then we write X is not an element of A in this matter. So, types of sets. Empty, as you can understand it from its name, the set that contains no element, or a set without element is called an empty set, and usually denoted by phi or simply this brace. Okay, empty set has a notation phi or the symbol. So አባል ሁሉ እኩል ተልዩ ታይባል ማለት empty set ይባላል ማለት by definition. So this is the definition for an empty set. We'll do an example later on. The other one is universal set. As you can understand it from its name, universal set is a set that contains all possible elements for a particular discussion or problem. It's the biggest set, and it's denoted by U. So if you have different types of sets like set A, set B, set C, then the collection of all these big sets is called a universal set. So a set that contains all possible elements of any particular discussion or problem is called a universal set. Right. Still we are talking about types. And the other one are subsets. So a set is a subset of set B. Say for example, a set A is a subset of set B, which is denoted by A subset of B if every element of A is also an element of B. That means if every element of A belongs to B, if every element of A belongs to B, then in this case we can say that A is subset of B. So that means A is part of B. So if this is so, we can say that A is subset of B. I can provide an example over here. Say, for example, you have set A. We know a set is denoted by capital letters. Then the entries can be 1, 2, 3, and 4. You may have another set B with entries like 1, 2, 3, 4, 5, and 6. Then what can you say about A and B? What can you say? So as you can see it, A has elements 1 to 4, 1, 2, 3, and 4. And B has elements 1 to 6, 1, 2, 3, 4, 5, 6, the first 6 natural numbers. As you can see it, every element of A are in B. So if every element of A are in B, then we can say that A is subset of B by definition. That means A is part of B. That's what we call a subset. Okay? All right. So I hope you got me. Now let's come to see a proper subset. So by definition, a proper subset has this definition. All right. A set A is a proper subset of B, which is denoted by A proper subset of B if A is subset of B and A is different from B. Let's take this side. A subset of B and A is different from B. What does this mean? That means A is subset of B and A is different from B implies that B is not subset of A. That's what it is. Okay. So if A is subset of B, or if A is part of B and A is different from B, in that case we can say that A is proper subset of B. I can provide you a simple example over here. Say for example, consider set A with interest, simple example, 1, 2, and 3. And let's consider set B with interest 1, 2, 3, and 4. So simple. Now, tell me about A and B over here. What can you say about A and B? Well, we can say that A is subset of B because by definition, we know that if every element of A are in B or belongs to B, then we can say that A is subset of B. Have you got me? But in this case, we know that A is subset of B, and you can see that the element in A and the elements in B are not equal. That means B has more elements and A has few elements, and they are different in numbers. We can say that. So in this case, we can say that A is not equals to B because we know that from equality of sets, if A is subset of B and B is subset of A, this implies A will be equals to B. So inequality of sets is not only in the number of elements, but also individual objects in the set element has to be the same in nature, okay? It's not the numbers. We'll talk about later on when you talk about the equivalency of sets, because equivalency is all about the number of sets, the number of elements, not the nature of the elements in it. So if A is subset of B and A is different from B, this implies that A is a proper subset of B. So our answer will be A is a proper subset of B. I hope you got me. Okay, that's a clear difference between proper subset and subset. Okay, good. Now let's proceed to the other types of examples related to subsets and proper subsets. So you guys have set A with these elements and set B with these elements, and you are asked to find or to explain more about A, whether A is subset of B, whether B is proper subset of A, whether A is proper subset of B. So what do you think? I will proceed one by one. Say, for example, let's consider A. Do you think that A is subset of B? Is A subset of B? That's the question. So you need to justify the concept of subset. That is, if A is subset of B, every element of A must be in B. Now, we know that 2 is in B, 3 is in B, 4 is also in B. But there is one element which is element of A, and one is not element of B. So from this, we can say that A is not subset of B. That means A is not part of B because every element of A does not belong to B. So our explanation here is that A is not subset of B. Now let's proceed to question B. All right. So is B proper subset of A is the question. Is B proper subset of A? So we have to justify again the proper subset concept. From the concept of proper subset, we know that if A is, or if in our case, in this case, if B is subset of A and A is different from B, then this implies that B is proper subset of A. That is the definition. Okay? If B is subset of A, at the same time A is different from B, then we can say that B is proper subset of A. Does the question satisfy this this concept? Now let's proceed. Well, B is subset of A. Is it right? So it is true, I think. Why? Because B is part of A, or every element in B, okay, every element in B belongs to A. So if this is so, we can say that B is, okay, I'm sorry, let's proceed to this case. So B is subset of A. At the same time, is A different from B? Obviously true, because the number of elements in A and B are completely different, though some of the number of elements and some of the elements are equal in nature. So to say that A equals to B, if A is subset of B, at the same time B is subset of A, but this doesn't hold true. In this case, A is different from B ልና ንውድእ ማለት እዩ። ስለዚ ናዚኣተን ኮንክሉዥን ናታ እዩ። If B is subset of A and A is different from B, then we can say that B is proper subset of A. ኢልና ነጠቃልል። ስለዚ the answer for B is that, is B proper subset of A? The answer is yes, because it satisfies the definition of proper subset. Good job. Now let's proceed to question number C. A proper subset of B. Is it true? Is a question. All right. Is A proper subset of B? So to say that if A is proper subset of B, if and only if A is subset of B and A is different from B, or B is different from A. Does this satisfy? Question C. Does this satisfy? Now let's proceed. A is subset of B. Is A subset of B? No, because A is not part of B. So A is not part of B. So it fails here, and automatically we cannot skip to whether A is different from B or not, because both has to be fulfilled. And hence we can say that A is not proper subset of B. That is a question. All right. So I hope you got me what I'm saying. Now let's proceed to the operation involving sets. So in this class, or in this session, we are going to focus three things. One, the union of two sets. Two, the intersection of two sets. Three, we are going to talk about also the complement of a set. So let's start by definition one by one. So when do we say that A is, union with B, or A union B? When do we say? In this case, if every element in A, or elements A and or B are both in A union B, or we can say that the union of two sets A and B is a set of elements that are either in A or in B. Or in other words, we can explain the set which contains every element of A and every element of B. This is called A union B. ኢልና ኣኑሳ A እና ኣብ B ለለዉ ኣባላት ብሓደ ጠቕሊልና እንዳህል ኣሚጥናዮም እንታይ ባር ስማርት እዩ A union B ይባል ማለት እዩ። እሺ ሓደ ከዓ ኢንተርሴክሽን ኢልና ኢንተርሴክሽን ኦፍ ቱ ሴትስ ተልና ኮመን ኤሌመንት ማለት እዩ። ኣብ ክልቲኦም ልግነ ኮመን ኤሌመንት ለምሳሌ the element that belongs to both A and B is called A intersection B ኢልና ንውድእ ማለት እዩ። Okay, this is a notation for A intersection B, and this is a notation for A union B. So the set of elements that are both in A and B, both in A and B, is called A intersection B, and if it's either in A or B, it's called A union B. All right, let's go to the examples related to A union B and A intersection B. Good. So let me proceed from this. You have A, set A with elements 1, 2, 4, 5, and 9, and B 1, 2, 5, and 10. Then you are asked to find A union B. Then how do you write A union B? How do you find A union B? Then you just write all elements in one, okay? Just the elements that belong to either A and B. Then we can say that 1, 2, 4, 5, 9, and 10, because we have 1 here, we have 1 here, we have 2 here, we have 2 here, we have 5 here, we have 5 here, we have 4, we have 9, and we have 10. Then we write it all as symbols. Then we call this one A union B, the set which belongs to the element either in A or B. This is called A union B. Now let's come to see the other one, A intersection B. How do you find A intersection B? In A intersection B, we are going to find common elements. نخلتهم نحار element ندلي. نخلتهم نحار element دلينا كأوتهم intersection نعمد مالتي. Let's see. نحار element من نيناوزي حدا نيناوزي حدا نينا. We write each one over here. خلتين نينا we write over here. حمشتين نينا we write over here. Okay. So the type بهرز مالتي A intersection B. The set which contains elements which belongs to A and B مالتي. Common elements. type بهرزي A intersection B لنزوع مالتي. إيشي. تخليتي لا أخذتم كوك ميلانير جنستي نسرح يا متكيزر. How it looks like. Let's proceed with this one. What do you think is A? Can you write it like in 3 ways? This is called set builder notation. Set builder notation. Set بثلاثة ملكة. Partial estimated set builder notation. ويخا completely estimating البالو ثلاثة ميتد اللونه. Set كنصحفه اللون خال. Partially توصل element نصحف نخال. Completely خا نصحف نخال ويخا بset builder notation ويخا in this way خا set نصحف نخال. مالتي بثلاثة غيرنا نصحف نخال. سلازي زي set builder تمالتي. The set of all x such that x is in between. Let's call this is I think 1 in between 1 and 3. You consider elements of integers in between 1 and 3. So what do you regard the elements over here? Because x belongs to z مالت the set of integers مالتي. سلازي among حدا among ثلاثة integer obviously فلتي. سلازي من اللي نعمت مالتي وزي خلتها مالتي. بيخ عملنينا elements 1 and then you are asked to find A union B. A union B means the set which contains either A or B. The set which contains elements that belongs to either A or B. لنا مثلا استنقبر مالتي نخلتي محاور حدا نخلتها مالتي A union B حدا either in one in B ركب خلتها خاء أو خلتي أمي خاء حدا أمي ركب لنا طبعا سلازي the set of all possible elements redundancy في كده set خلتي الخاء تمسك خلتي صحفي already if it's element then you have to write it one time مالتي تجزي سلستجزي سلالي صحف مالتي لا intersection تخيلنا خاء A intersection تخيلنا خاء تعنا نقبر مالتي common element ندلي. Do we have a common element here? Of course yes. تريوار لهم زيها common element لنا مالتي. I'm gonna write over here the common element obviously is 2 and then let me make it this is the A intersection B مالتي. سلازي بقليل تردي هم بالقمة اللني أصلنا لا third part اللي نقول خمنا تا set operation complement of a set اللي نخل complement مال without مالتي. أف set theory دحار لا تمارهم وتمزيهم بزح probability concept ون applications للو set probability بزح application سلالة قد مثل رقم تخذ يخم تشعر سري ما جرشة ولا عسرت حد عسرت خطلا زح مصغرهم بصف يحتروا يخم نا complement of a set تلنا تمالتيو complement of a set ويخا A bar or A complement لنا بخلتي دينوت مقارن نخلينا تايلو لذي A complement مالت without A مالتيو the elements in A which are not in A but in U بحصيرو the complement of a set A refers to the elements in the universal sets in the biggest set which are not in A مالتيو without A مالتي كاب A which الجنة كله تابع complement of A مالتي بقينا خذك نوصل example استنسرح يا زيا easy لخونة example لا تنا good job لازم ساي يوم اللي يقمت تياجي تليكم يا down the live session down the tube you can just give me a comment give me a question one time and again let me remind you once again if you just participate well then you will have a reward at the same time you may be eligible to certain scholarships which is given in this education and training policy guys okay so let's continue so we have here a complement elements of the universal sets that are not in A or بحصيروا لا أخذتم كردكم تاتلو without A have A which للو يخم so you have the biggest set here and you have a set over here so a complement لكم have A which الجنة أوتر تطرح jot down تقولوا مالتيو شيء so 1 2 3 exclude غيرهم زيهم أو إيش للجنة بليزيهم circulate غيرهم توصلون بملأ 4 حمشت سلسة يخون لمرتي 0 4 These are called A complement or without A. Elements of the universal set U that are not in A. إننا نتعال السي خليت للتي كيستنريا. You have U, the first 10 natural numbers مالتي 1, 2, 4, 5, 6, 7, 8, 9, 10 and you have set A. This is your universal set and these two sets which are subsets of the universal set U, obviously. So the set of all x such that x is a positive factor of 10 in U. And B is the set of all x such that x is an odd integer in U. Then you are asked to find A complement and B complement. So how do you deal with this? Without A malati, you are going to find elements of the universal set which are not in A malati without a positive factor of 10 in the universal set. So how do you find it? Is there any value, any number in the universal set which is not a positive factor of 10? لمثالي 1 10 is a positive factor of 10. 2 which is a positive factor of 10. Is 3 a positive factor of 10? No. Then we write it. Then 4 a positive factor of 10. Is 4 a positive factor of 10? No. Then we write it. 5 a positive factor of 10. Is it? Yes. Then we just give a note. Is 6 a positive factor of 10? No. Then we write it. Is 7 a positive factor of 10? No. And we write it. Is 8 a positive factor of 10? No, again here. We write it. And finally, is 9 a positive factor of 10? Which is not. And then we write it. But 10 obviously is a factor of 10. Then we just ignore it. Then we take this one, we take this one, we take this and this. So without A ማለት እዚኣቶም ማለት 3 4 6 7 8 9 ና 10 ፋክተር ሊኾኑ ጥራሕ ኢኹም ትጽሕፉ ማለት እዩ 3 is not a factor of 10 4 is not a factor of 10 6 is not a factor of 10 7 8 and 9 is also is not a factor of 10 ማለት እዩ ስለዚህ እዚኣተን ትጽሕፍዎን ማለት እዩ ጽቡቕ ዜና ኮምፕሊመንት ኢና ነና ሽካዕ ከዚ ቢ ስንኽድ ቢ complement the set of all x is that x is an odd integer in U. Odd integer in U. So you focus on odd integer in U and without odd. تلنا تمالتي لغلنا خلطو بشيني إننا. Without odd تلنا تايخون لمالتي. Even يخون لمالتي. لازم تاخون focus تقولوا without B مالت you focus on the set of all x that such that x is an even integer in U لهم check تقولوا مالتي. Without B تلكم or تخينوا without B لخون لخل تمالتي even. سلازي even number طرح focus تقولوا. مني الناوزي ما كنا قرأني خل إزيا خلتها أصيلو even لخوانه then قصيلنا شدشتا قصيلنا شمونتا قصيلنا عسرت سلازي هاي نقبر مالتي وزي 2 4 6 8 and 10 what are they? These are positive factors of not positive factors is an odd integer without an odd integer without B تايبال زياتهم مالتي بحصير بالset builder notation تقميط لهم زياتهم the set of all x is that x is an even يكون له مالتي an even integer in U زي أمرسها ما عريان زيادة يتبال زيادة complete listing method تبال we list all the elements complete list زيادة يتبال set builder notation تبال زيادة exactly opposite نا B complement the set of all x is that x is an even integer in U تيلة تمالتيو زيادة نامن مالتي نا B complement مالتي نا B complement the set of all x is that x is an odd integer without or تيلكا even without even تيلكا odd مخان بغلي لكتر دوا من تان مالتيو. Wonderful. Now, I'm going to take you to pictorial representation of sets. Set, the Venn diagram concept is a well-known mathematician after John Venn. John Venn تسرحيو. He's a good mathematician. Well-known mathematician actually. So, Venn diagram, I've said theory, operation on probability, probability concept of Sussex, which operation on probability كنا أتتلنا ትሪኡ ኢኹም advantage na Venn diagram ማለት እዩ لما አንተ ግን ኣብ set operation pictorial representation of sets እና ክንገልጸው ክንሞክር ኢና example provide ገሩ ክንሞክር ኢና so it's not only two circles you may have also 2 3 or 5 circles okay under the umbrella of universal set okay ኣብ universal set ውሽጥ ኮይኖም set operation define ክንገብር ንኽእል ማለት ስለዚህ Venn diagram ታዩ ተልኩም visual representation of sets and their relationship ማለት እዩ so you may have set A and you may have another set B and they are corresponding elements so they are circles to represent sets and overlapping areas to show intersection ማለት overlap area ልባህል እዩ እዚኣቶም ታይባሉ overlap areas ይባሉ overlap areas ይባሉ ስለዚህ ኣብዚኣቶም ብዙሕ ናቱ አንቶል ንገልጽናዮ ኦፕሬሽን ሰለስተ የነዚያ jot down ገይረ ክንነግረኩም A union B ተልኩም you just shed all the areas እዚ በሙሉ እዚ A union B ለምሳሌ A union B ኣብ ያንያ ተልኩምኒ you just write all elements in A and B ታይም ገበር ማለት እዩ ሁሉ እዚ ሼድ ትገብርዎ ማለት እዩ A union B ነው ማለት A intersection B ተልኩም ካ the set I mean the intersection of the two sets ክባል ተለታ ማለት እዩ elements that belongs to both A and B ኣብ ይግነ ማለት እዩ ኣብዛውዝንያ ማለት እዩ this is called A intersection ቢልና እንትንውለ ማለት እዩ እሺ A complement እና B complement ኸበ እዩ ተልኹምኒ A complement ማለት without A ማለት ካብ A ውጪ ልኾነ ካብ A ውጪ እንታይ ይባል ማለት እዩ እዚያ A complement ይባል B complement ካብ B ውጪ ታይባል ስኻ B complement ካብዚ ካብ B ወፃይና ካብ A ወፃይ ተል ይኹል ግዜ B complement A complement እና እዚኣ ተማኸለላ ተባ A intersection B A union B you shaded all the areas and the biggest set which contains all these two sets is called the universal set ስለዚህ Venn diagram በሐጽሩ ና set theory concept በሐጽሩ ለረደና በሐጽሩ ኩለን set operations ነውግዕነርና አዚያ pictorial በቀሊሉ explain ክንገብር ንኽእል ምዃና ከረድአኩም ደልየ ማለት እዩ good job so can you provide an example then of course yes so consider these two sets set A and set B and these are the elements we have and you are asked to find A union B A intersection B and A complement the solution of the above ክጽፋሞ then you will understand it how it looks like so A union B ተልናሲ ታይና ንገብር ይኸዚ A union B ማለት the set of all elements A that belongs to either A or B ኩለን ተጻፍዎን ማለት በሙሉን እዚን ለሎ ስለዚህ ይሆናል ሁሉን በሙሉን ክለኩም ተለኹም ኣብ A እና ኣብ B ውሽጥ ለሎ ማለት እዩ so we have 2 we have 3 we have 7 we have 9 we have 10 and again we have 12 and we have again 15 and finally we have 16 ታይባል ዚ ማለት እዩ A union B elements that belong to either A or B so this is A union B and let's come to see intersection B همتان عنتول ገለጽ خلكم A intersection B ማለት common element ነኽልቲዮም ማለት እዩ common element عنتول ሼድ ገርና ያለና ዚኣ ማለት እዩ common element ማለት ለኽልቲዮም ለኽልቲዮም ሴትስ ልገልጸና ኸዓ ኣብ ኽልቲዮም ልግነዩ ኣባላት ማለት እዩ ስለዚህ ታይባል ዚኣቶ ማለት እዩ 7 እና 3 ካው 16 ኢኹም ጆት ዳውን ትገብርዎ ማለት this is called intersection B ማለት እዩ the last part ና A complement እዩ ولا B complement አትለና ለንወስኽ ንኽእልና ተደሊና A complement ተልና ታዩ A complement elements of the universal set a set that belongs to the universal set but not A ማለት ታምልት without A ማለት ካብ A ውጪ ለሎ ሁሉ ካብ A ውጪ መንኒና ካብዛ ሰርክል ዚኣ ካብ A ውጪ መንኒና ክልተ ኔና 15 ኔና 12 ኔና 14 ኔና 8 ኔና ስለዚህ we write them like 2 then 8 then 12 then 14 then 15 this is called A complement B complement ከተጠየቀኩም ሃሜት ገሩ B complement ካብ B ውጪ ካብ B ወፃኢ ለለው ሁሉም ታዩ መንኔና እዚ 8 ኔና 14 ኔና 9 ና 10 ስለዚህ 8 9 10 ና 10 ኢልና መስና ነው ማለት እዩ ስለዚህ ሰለስተ ቤዚክ ኮንሰፕት ና ሴት ኦፕሬሽን በቀሊሉ ሪና ነና ማለት እዩ the union of two sets the intersection of two sets and the complement of two sets ማለት እዩ። Do you have any question? You may raise any question if you don't understand anything on the concept of set operation. Guys, to remind you once again, this is a merged summer camp summer course for grade 9 and 10 together. You may think of we are revising questions, subjects from grade 10, but you know we'll see also some concepts from grade 10 later on. Okay, نعسرة ناتش عكفلي نانر لنا كيتول عسرة كفل اللهم نالات اللي خوزي حر مرجد خوين سلالة رغاز قليلو لردوكم concept كلي بقليلو كردوكم it will be wonderful for you guys. Okay, I hope you got me what I'm saying. All right,
Teacher, I have a question.
Okay, do you have any question?
Yeah, the number 8 and 14 in the diagram.
Yeah.
Are we consider them as a universal set elements?
Of course, yes. Okay, so thank you very much. Can you tell me your name, please?
My name is Han.
All right, Han. Nice to meet you. All right. Okay, let me explain you once again. The universal set is the biggest set. When we say, then it means it includes all elements in A and B, including outside A and B. That means the universal set is a set which contains A union B, 1, A intersection B, 2, A complement, 2, 3, B complement, 4. كلهم آلات الحذف. كلهم آلات. لازم. Okay. Keep on.
Thanks, I understand now.
All right. ስለዚህ شمنتي 14 B complementنا A complement آلات ኮይኖም ግን نخلتيهم آلات ከዓ من حزوم نيو the biggest set U, the universal sets. Okay. That's what I'm saying. All right. Thank you very much, Haben. For do you have any question? Any members on the online? Any question? Good job. All right. So guys, this is all I have for today's session. Okay. On the next session, we'll continue on the concept of related to set theory, polynomial function, and so forth. If you have any question down the link, you can just write it and I'll answer it quickly. Thank you for having me and nice to see you once again. Bye-bye.